Right, tuh. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam
Waalaikumsalam
warahmatullahi
warahmatullahi
wabarakatuh.
wabarakatuh.
So, good evening, everyone. We're Group A from the 72nd class of the Introduction to Engineering Design class of FTMD International, consisting of myself, I'm Naufal Afif, 169193666.
Rayhan Ekananto 169193334.
Rafa 1691932
and Bima 1691937
So today we're going to present our solution to the solid waste problem that are filling up the rivers of Bandung.
First of all, current status and prevention matters. Bandung in 2017 has produced 1,600 tons of solid waste or waste in particular, with 4,419 TPS or tempat pembuangan sampah located in Bandung. There are still severe consequences such as flood, decreasing water quality, and disease chance increased. Even though the government of Bandung has done many efforts such as Kang Pisman and Pasal 49 Ayat 1, there are still many problems that are left undiscussed, which is why we came with a solution of our own.
So basically the definition of problem is solid waste is one of the most highly produced and possess the potential to be the most harmful to the environment when they are not treated properly. And in the city of Bandung, one of the most harmful category of solid waste would be the plastic organic waste that comes from different households. And most of these households are located in areas like the ghettos, which do not have the facility to process their waste properly. So instead, they just throw them into the river, and it doesn't just pollute the river, but it would also produce unpleasant odor. Therefore, a proper solution is needed to manage these harmful disposals, and our group proposed an automatic waste collector to tackle this issue. And the project description would be a device that collects solid waste from water bodies such as rivers and sewers, like I've mentioned before, thus preventing it from clogging the flow and also cleaning the water. This device gets its powers from hydropower generator, which will be discussed later on. And the design requirements is one, economically advantageous, two, can be used in several locations, and the third one is simple and easy to manage. And the objective is to generate an effective and eco-friendly solid waste management solution and to simplify the process of cleaning the environment, especially the water bodies. And the engineering requirements is basically waterproof because we would use it in water bodies. Second one is from the riverhead. The waste collector has to be low enough to maximize the collection of solid waste, but also high enough to not disturb the aquatic flora and fauna life. And the third one is it should be able to withstand the weight of its own and the added weight, which would be the collected waste. And the waste that are collected should be easy to transport into the place where we would process it next.
In design background, first of all, our group have four design, and each design have its pro and contra, have its plus and minus. After some discussion, our group choose the design for. In this design, in the design for, we use mini turbines to power the electric motor, which is we don't need some money to make this thing works. We use the river flow to make the electricity. About the basket and how the basket collect the waste, the motor will make the basket move. First of all, the basket placed above and behind the iron net, and when the electric motor start, the basket will slowly go in front of the iron net and slightly go down to the river to take out the waste. For the small waste, it will go to the tempat pembuangan sampah yang bagian di atasnya. And this motor will run the program which have function to take out the waste every 3 hours, and this waste will be then divided to groups manually by human to each kind properties to be recycled.
So this is the detailed design concept. I'll just get my laser pointer up here for a second. That should be enough. So what will happen is, initially there will be dirty water with trashes floating about, flowing into the metal grate. This metal grate is basically a slanted conveyor belt which delivers the waste into the basket hanging above. The baskets hang above and basically also something of a conveyor belt, more like a trolley system powered by 2 electrical motors on each banks of the river. After the waste is separated and put into baskets, they will send down its chutes and into a conveyor belt. When the waste that has been collected from the river will be separated into each waste kinds and that will be processed further. Downstream, there are two mini hydropower turbines with embellished designs to operate on low flow conditions. If if there's no enough water flow to power these mini generators, we could just use a generator to power the electrical motors that are driving both the conveyor belt here and the electrical motor on each side of the trolley system. So the design uniqueness that we present here is that it uses water flow to power the machine and uses basket that works automatically. So that's all that there is to it. And also, there's also a question about why did we use steel grates as opposed to something like plastic or aluminum, and such that our reasoning is because steel, more specifically stainless steel, can withstand more loads than aluminum or plastic, and because of its anti-rust capabilities, can also be operated in conditions where water is present. And here is the prototype design. You can see that you can see the more detailed design from the last slide look as such. Here are the steel grates and with waters with waste in it, carried up to the basket with electrical motors on each side in each bank of the rivers, along with the mini hydropower generators located downstream on each bank of the rivers, powering the electrical motors, which operates the operates the trolley system on the top here. Later on, this waste that are on this baskets will drop down the chute and will be processed further off the river.
Okay, so for the implementation plan, our prototype will mostly located in the Cikapundung River, located in city of Bandung. And according to the data by citarum.org, the Cikapundung River has 50 TPS throughout the flow, which is why it's a highly effective river to put our machine. And it also has plenty of rubbish buildups throughout its flow. Putting the machine near the TPS will make the transport for the waste easier, and budget for this project is divided into creating the machine and maintenance, and we hope that the city government can help with the funding since it's supposed to be not that expensive. And since the machine works automatically, a crew is only needed for maintenance to make sure the machine is in primary condition. Next. So reflection, what we learned is the importance of waste management, the drastic impact it is on our environment. The engineering innovations can be used to help major and minor problems, and the importance of working together. Possible improvements are basket moving in other directions rather than only up and down, and the ability to detect and separate trash automatically. And the chances of implementation, yes, it is highly possible since it powers itself and requires minimal funding. with suitable testing sites such as the Cikapundung River and the Citarum River.
And that is all from our team. Thank you very much for watching this presentation. Wabillahi
Now,
taufiq wal hidayah. Yeah,
now
yeah.
for the questions from the docent.
So the
Oh yeah.
lecturer gives us three questions. I will read the three of question. The first one, please explain the mechanism of how the machine will be able to take the garbage. Two, what kind of hydropower source that you will use to generate the electricity, like pro hydro or mini hydro or something else, and why? Then also the power requirement for your system. The last one is why you use a metal net instead of the net made of synthetic materials. How you deal with the corrosion problems and flood problems. As you know, when the rain season, the water level usually unpredictable.
Okay, so I will answer number one. The machine has a steel mesh conveyor belt that operates constantly. These conveyor belts pick up the trash from the water to be carried away by the trolleys. The trolleys are set to go up and down from the conveyor belt to the bottom of the river every few hours. It goes down every few hours with the help of a certain programming tool that acts as an alarm clock. Once it goes down, it stays there for a few minutes, then rises to bring to bring the trash to a container for further processing. Number two.
Okay, so number two, the question is regarding the how would it be powered and by what? So the electrical source would be a mini hydropower generator, which would be put uh, inside. I mean, in the river where it has the clean flow. So it would be behind the machine, and so it would also be coupled with impellers designed to efficiently operate in low flow rivers. And on both banks of the rivers, these generators will hopefully generate enough electricity to power the motors operating the conveyor belt and also the trolley system. And if there is a case where the river flow isn't strong enough, we can simply use a generator as a power source since our main focus is solid waste management.
And I will answer question number three. Why do you use a steel grate instead of things like aluminum or plastic as the conveyor belt in the system that interacts with the river? First of all, steel is strong. It can withstand more loads than aluminum or plastic, and due to its rust repelling capabilities, it can also operate in waterlogged conditions, such as conditions presented in our project here. Lowering the maintenance cost for the conveyor belt also pushed down maintenance costs on the whole machine. Therefore, we use stainless steel grates instead of aluminum or plastic grates.
Okay, I think that's it for this presentation. Thank you very much and have a good evening.